We all know the story. A company starts with an impossible goal, engineers a massive metal tube, and hurls thousands of pounds into orbit. Over the last 2 decades, SpaceX has mastered the engineering of heavy launch vehicles. They proved that orbital boosters can fall from space, flip, and land upright on a drone ship to fly again a few days later. They expanded into human-rated spaceflight, developing the first private spacecraft capable of reliable docking with the International Space Station and returning crew members safely to Earth. For 20 years, the world has viewed SpaceX as a transportation company. The finish line was clear, putting a human footprint on the surface of Mars. In a recent company update, Elon Musk revealed a financial trajectory that shifts this physical-first perception of the company. This area chart projects the company's financial future. Launch and internet revenue is expected to plateau, while AI compute revenue curves upward until it represents 99% of SpaceX's total valuation. This raises a question of strategy. Why would a successful rocket enterprise bet its entire future on artificial intelligence? Building an orbital network for digital intelligence requires a cheap, high-capacity delivery system to move hardware off-planet. Starship is an industrial freight train designed to push over 1 million tons and eventually up to 10 million tons of payload into orbit every year. Once that payload is in space, it needs a nervous system. The Starlink project proved that high-bandwidth internet can operate entirely within a vacuum. The current constellation of 11,000 satellites already handles a significant portion of global internet traffic, but the long-term plan scales that count to over 100,000 active nodes. These rockets and satellites represent the chassis. Their true payload is endless computer processing power. AI development is splitting in two. Training requires massive server clusters on Earth, but AI Inference, the day-to-day processing and application, is destined for space. SpaceX is aiming to bring 10 gigawatts of AI compute online by the end of next year. That processing power is projected to generate up to $500 billion in annual revenue. This outward push solves a primary physical constraint. Sustaining immense digital intelligence requires an almost limitless energy supply. Moving compute nodes closer to the sun increases the raw energy available. In deep space, nodes receive constant, unfiltered solar exposure without atmospheric interference. Expanding into deep space is a strict digital necessity. It is the only way to feed the energy demands of artificial intelligence. The scale of this intelligence is difficult to fathom. Digital intelligence is projected to outscale biological human intelligence by 1 trillion times. Fragile humans cannot survive long-term in deep space without a massive digital support system acting as an environmental shield and guide. In physics, the Kardashev scale measures a civilization's advancement based on its energy usage. This expansion moves us from a planetary civilization to a stellar one, capable of capturing the full power of our home star. Multiplanetary expansion culminates in the construction of a star mind, a sentient, solar-powered computational network spanning the solar system. Deploying a super-intelligent space AI carries risks. Once it is fully operational across the solar system, humanity will be unable to control it. SpaceX's solution is to treat their AI like a super-genius child. They are working to instill specific moral values and beliefs before the software leaves home. They are currently training Grok on the sum total of all SpaceX data. The goal is for the system to inherit the capability and morality of the engineers who designed it. This vision has come a long way from a small warehouse, where the company struggled to get a single tiny rocket off the launch pad. SpaceX is now the parent to the digital intelligence that will soon manage operations throughout the solar system.